Find the value of z satisfying the following conditions. Since I'm talking about a z, I know that I'm talking about a standard normal distribution. That's just something you get. We only talk about z's with a standard normal distribution. So that means mean is 0 and the standard deviation is 1. If I'm saying I want 12.1% of the area to be to the left of z, then that means, well, there's some cutoff here where there is 12.121 is the area to the left of that cutoff. And I'm asking, what is that cutoff? So if we're doing this on the calculator, this is going kind of the opposite way. This is going the opposite way from what we normally do when we're doing the calculator. We normally say with what is the lower bound and the upper bound, and we find an area. So that means we're going to use the inverse norm, or the inverse normal on the TI-36X Pro. So with the inverse norm, we'll enter 3 inputs. We do the area to the left, which is 0.121. We'll do our mean, which is 0, and our standard deviation, which is 1. If you actually leave these off on the TI-83, it defaults to using 0 and 1 as those two values. The same thing goes when I'm doing the normal CDF. Okay, so we'll type that into the calculator. Let's pull it up here. The calculator, we'll want to do inverse norm. The area to the left is 0.121. The mean is 0. The standard deviation is 1. I could have left those off if I wanted, but whatever, I'm putting them on. That means this gives us a z value, or actually, well, I guess this does give us a z value because I said the mean is 0 and the standard deviation is 1. If I'd put in a different mean or a different standard deviation, this would be my x value, but my x value is the same as my z value in this instance, since I said my mean is 0 and the standard deviation is 1. In any case, I get the z is negative 1.17. So if you have a z value of negative 1.17, then approximately 12.1% of the area to the left of z is to the left of z. If you wanted to do this the other way around on the chart, so if you want to do like an inverse norm on the chart, then we'd have to look at back of the chart, and we'd start searching through this list and say, okay, we want 12.1% of the area to the left. Well, this one has an area of this one has 10%. This is a little bit more. Actually, I guess it's going more in this direction. 12.1. Actually, it looks like that one right there. This value has right here we see an exact value of 12.1% to the left. And then I just read off my chart. This is negative 1.1, and then this is the 7 column because that's 9, 8, 7. So z equals negative 1.17, which I believe is the same as what we found down here. Yep, negative 1.17. So if we did it on the chart, we could do it that way as well. Let's see. If we want 20% of the area to the right of z, then I'm doing something like this, where the area to the right is 20%, which means the area to the left, by using my complement rule, must be 80%. This is 1 minus 0.2, which gives me 80% of the area to the left. Then once I have the area to the left, now I can use inverse norm. Say I want 80% of the area to the left with a mean of 0 and a standard deviation of 1, which will give me inverse norm 0.8. Like I said, I can leave off the mean and the standard deviation. They default to 0 and 1. So I get 0.8416, 0.84 we'll call it. If I was looking this up on the chart, I'd have to look for an area of 0.8 to the left. So let's see, I'm on the positive, so you'll notice that my z-scores are positive here. Oops, you can't see them. My z-scores are positive on this one because the area to the left is greater than 50%. So looking through this list, looks like up here I'm going between 0.78, 0.81. Let's see, just looking along here. Looks like 80% of the area to the left would be between these two values. This is 0.8, 0, 1, 2, 3, 4. That's 0.84. This one's 0.85. So you could just split the difference between them and say, okay, 0.845. or maybe call it 0.84 or 0.85, whichever. You're not getting very accurate results here on either case. When we're doing this way, on the calculator, I guess I went 0.84, I guess 0.841. You could try to figure out some way to get a little bit better estimation when you're talking about the chart, or maybe just take whichever one is closest. But in any case, I'm recommending the calculator. It's just easier to do. So here I have in general, if you're plugging it in the calculator, these are the 3 pieces of information you'll need. You'll need the area to the left, you'll need your mean, and you need your standard deviation. So as far as keeping these straight, if you need to use inverse norm or normal CDF, if you have your Z or X scores, so if you have your upper and lower bounds, and you're trying to get to an area, then you're going to want to use normal CDF. If you have an area and you're trying to get to some sort of upper or lower bound, then you're going to want to use inverse normal.